Hi everyone, this is group 2 and I'm Jason Kang. So mock test for question 2 part A. The question is, Paul has prepared 5 questions in descriptive statistics, 10 questions in probability, and 12 questions in probability distributions. From these prepared questions, 9 will be selected randomly for the quiz of statistics that will be held next week. What is the probability that the quiz will consist of 2 questions in descriptive statistics, 4 questions in probability, and 3 questions in probability distributions? Here's the solution. The most important part here is that we have to use combination, not permutation. This is because permutation is only used when there is order in the given sample, but this question does not count order. So combination formula should be applied. I want to point out the basic concept of combination, which is that it is a collection of n objects taken r at a time in any selections of r objects where order does not count. The number of combinations of n objects taken r at a time is ncr equals to n factorial divided by r factorial bracket n minus r bracket close factorial. Back to the question. Probability of 2 questions in descriptive statistics, 4 questions in probability, and 3 questions in probability distributions, and selecting 9 questions out of 27 questions can be illustrated by this formula. 5C2 times 10C4 times 12C3 over 27C9, which I can get 560 over 5,681. This picture is how I solve the question. The above one is the denominator and the below one is numerator.
Okay, hello everyone, I'm Wendy, and I will solve the problem here. The question is, a survey is conducted to study the customer behavior of a convenience store. It is found that 70% of the customers patronize the convenience store every day, and 56% of the customers purchase newspapers. For those customers who patronize the convenience store every day, 75% purchase newspapers. So the first question is, calculate the probability that a randomly selected customer neither patronizes the convenience store every day nor purchases newspapers. So let's assume that A is equal to customers patronize the convenience store every day, and B is customers purchase newspapers. So the probability of event A is equal to 0.7, and the probability of event B is 0.56. Under the condition of event A, the probability of B is 0.75. So the answer is the probability of neither A nor B is equal to 1 minus the probability of either A or B. So just calculate it like this here, and we will find the outcome is 0.265.
I'm Alex. My question is look for question 2B, the second one. Given that a customer purchases newspapers, what is the possibility that this customer patronizes the convenience store every day? So this is a question about conditional possibility. Still, the event A, the customer patronizes the convenience store every day, and the event B, customer purchases newspapers. You already know that the possibility of event B is 56%, and the possibility of intersection of event A and B equals 70% multiplied 75%. That equals 52.5%. So the conditional possibility of A given B equals this, and it finally equals 93.75%.
Everyone, I'm Jim. I'm going to deliver question 3. Given that a consumer does not patronize the convenience store every day, what is the possibility that the consumer purchase newspapers. And the question tells us that the possibility of consumers who go shopping every day is 0.7. And the possibility of consumers who buy newspapers is 0.56. We can assume that consumers who don't go store every day and buy the newspapers are event C. First, we can use the complementary rule as is shown on the PPT. We can get the possibility of the customers who don't go store every day is 0.3. And second, we can use the multiplication rule as is shown on the PPT. We can get the result directly. And the result is 01167.
Hello everyone, I'm Hans, and today I will solve the question from Mock 1 Q2B. Let we see the question first. There are 3 members of a private country club have been nominated for the office of president. The probabilities that Mr. Chen, Mr. Li, and Mr. Chen will be elected are 0.3, 0.5, and 0.4, respectively. Should Mr. Chen, Mr. Li, or Mr. Chen be elected, the probabilities for increase in membership fees are 0.8, 0.1, and 0.4, respectively. If someone is considering joining the club but delays his decision for several weeks, only to find that the fees have been increased, what is the probability that Mr. Chen was elected president of the club? So let we see the solutions. The solution for question 2b. First, we assume that A equals to the increased fees, and B1 equals to the probability that Mr. Chen was elected. It equals to 0.3, and B2 equals to the probability that Mr. Li was elected equals to 0.5, and B3 equals to Mr. Chen was elected, and the probability of B3 is 0.2. So, given the conditional probability of event A given event B1 is 0.8, and the conditional probability of event A given event B2 is 0.1, and the conditional probability of event A given event B is 0.4. So under the condition that given event B3, we need to calculate the conditional probability of event A. So we should use the Bayes theorem. As we can see, the given event A, the conditional probability of B3 equals to the probability of B3 multiply the given event B3, the conditional probability of A, to divide the probability of B1 multiply the given probability B1, the conditional probability of event A, plus the probability of B2 multiply given the event B2, the conditional probability of A, and plus the probability of B3 multiply the given event B3, the conditional probability of event A. So the final probability of given event A, the conditional probability of B3 equals to 0.2162. It is the solution of my question.